So now we're going to have a look at the quotient rule. So we're not going to derive that. It's derived in a similar fashion, but for the sake of brevity, it's not as good visually. So if f and g are both differentiable, then we can use the quotient rule to find the derivative of their quotient. So notice that this involves a negative or a subtraction, and it's also a fraction itself, so it's a little bit more involved to remember. So it's the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator all over the denominator squared. So 2 points to remember with the product rule. It doesn't matter what order you have the derivative of the first term. If you took the derivative of the first or the second, it doesn't really matter because you're adding them. As long as you're taking the derivative of one and multiplying it by the original function of the other, it doesn't matter. Here, the order matters. You need to have the derivative of the denominator in the second term. That needs to be subtracted. And then also don't forget about having it over the original denominator squared. So look, here's an example for the quotient rule. So our numerator is x squared plus 1. Our denominator is x cubed minus 1. So we find the derivative of each of those separately. So the derivative of the numerator is just 2x, and of the denominator it's 3x squared. So then applying the quotient rule, we have the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. And so then we just multiply that out. And this is our derivative. Here's another example. Find an equation of the tangent line and normal line to the curve at the specified point. And remember, the normal line is perpendicular to the tangent line. So recall from algebra that a perpendicular line has a slope that's the negative reciprocal of another line. So here is our function, and we want to find the tangent and normal at the point 1, 1. So we know that we need to find the derivative and evaluate it at 1. So the derivative of the numerator is simply 2. The derivative of the denominator is simply 2x. So we use the quotient rule as the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator all over that denominator squared. And that's the function that we get. And now we evaluate it at 1 to get the slope of the tangent at that point. Well, you can see when we evaluate this at 1, we get 0. So the tangent line is horizontal. So we have a horizontal line through y equals 1. So this graph must have a minimum or maximum there. And then the normal line is the line that is perpendicular, and of course a vertical line is perpendicular to a horizontal line. So since it goes through the point 1, 1, the normal line must be the point x equals 1. And there you can see that graphically. That was a max, a local max. And there's our tangent, and there's our normal. So one little thing to help make life a little bit easier, when you're given a quotient, a lot of times it's easier to figure out how you can simplify instead of just applying the quotient rule, because the quotient rule gets a little bit messy. So you can either see if you can simplify first or turn it into a product possibly, because the product rule is a little easier to work with sometimes. So in this example, notice you have a quotient, but since you have a common denominator, it's easier to just simplify using that common denominator and then differentiating term by term with just the power law. So then just using the power rule, and this is our derivative, and that's a little bit easier than having done the quotient rule. So here's a summary of all the differentiation laws we've talked about up till now. And that's it.